looking at this first one over here on the left, we have negative 2x squared plus y all raised to the second power. How many of you think from right here, we're just going to use properties of exponents? Raise your hand. Couple. How many think you're going to not do that? Raise your hand. You have to vote one way or another. Let's vote again. How many of you think that you're going to use properties of exponents right here? Raise your hand. How many of you think you're not going to do that? Raise your hand. Okay. Interesting. Those of you that raised your hand second, you would be correct in this one. If I was to just raise both of these things to the second power, I'd be breaking the forbidden rule because of that plus sign. So does everybody see the plus sign? We can't just square the first thing, square the second thing. We cannot do this. We'd have to rewrite this one as negative 2x squared plus y times by negative 2x squared plus y. Because of the plus sign, you cannot just square the front thing and just square the second thing. Do you all understand that now? Okay. So you'd rewrite it like this, and then you would distribute and multiply. So negative 2x squared times by negative 2x squared. 4x what? 4. Good, Garrett. 4x to the 4th. When you multiply the same base, you add your exponents. Negative 2x squared times y. Okay, negative 2x squared y. I've distributed negative 2x squared to everything over here on the right. Now I'm going to distribute the positive y here. Positive y times negative 2x squared. Oops, I forgot to write that one. Negative 2x squared y. And then y times y. Y squared. And it's positive y squared, right? So then we would combine like terms. So we have 4x squared. 4x to the 4th. No other x to the 4th, right? Negative 2x squared y minus 2 more x squared y's. How many x squared y's? Minus 4. Do I add those exponents? No, they're just like terms. We're not adding anything when combining like terms. So 4x squared y's and then plus y squared. Did this make sense, guys? Because I can tell that we need to, I'm going to put it on the next test, something like this for sure, because I can tell more than half of you don't know it and you need to learn it. Did this one make sense? Okay. So don't make those little errors. Remember, when combining like terms, we don't add our exponents. Okay, looking over here on the right now. So now over here on the right, do you see a plus or minus sign in there? No, so we can simply take all that stuff and raise everything to the second power. So I have negative 2 to the second power, right? I've got to distribute it through to all of these things. Now what am I doing with my exponents? Multiplying. This is raising all these powers to another power. So we're, again, what's my power on 2? 1. So 1 times 2 is 2. That's where I got negative 2 raised to the second. 2 times 2 for x is x to the 4th. And then what's my power right here? So 2 times 1 is, so y squared. Then from there, we would simplify it one last step. Negative 2 squared. If you're going to type it into your calculator, you've got to use parentheses. Because negative 2 squared, by definition, means negative 2 times negative 2, which is positive 4. So we have 4x to the 4th y squared. Okay. Now, these problems look very similar. The only difference was that plus sign. But do you see how huge of a difference it makes? Okay, huge difference. So keep that in mind. All right. No questions on this. Okay. All right, let's do the news test. So today's 2-8. Title that 2-8 in your notes. So today we're going to be dealing with roots and radical expressions. The nice thing is we've practiced this actually quite a bit, stuff dealing with this. But today we're going to extend our knowledge a little bit further. Because in secondary 2, you have to be able to do this. But in secondary 3, you have to be able to do this and apply a new rule. So we'll get to that new rule in a second. So just keep in mind, with every power, so if we have degree 2, then there's going to be a square, there's going to be a root that corresponds to every power. So if there's degree 2, there's a square root that corresponds. So if there's degree 3, then there's a cube root that corresponds. If it's degree 5, there's a fifth root that corresponds. So does everybody get the pattern? So if I had degree 100, root would correspond? The 100th root. Very good. So just keep in mind every power has a root that corresponds. Okay, now think about this with me. 5 squared is equal to positive 25, right? Now by definition, then if that's true, if 5 squared is equal to 25, then the square root of 25 will be equal to 5. Okay? Now once again, negative 5 squared is equal to also positive 25, right? So by definition, just like up here, by definition then, what is the square root of 25 equal to as well? Negative 5, right? Now this makes sense, guys, because we learned this. If you're taking a root, a square root, an even root is going to have a positive root and a negative root. Positive root, negative root. All right, so let's look at something to the 4th power. So 5 to the 4th power is 625. So what do you think 625, the 4th root of 625 is? You don't even have to have a calculator. 5. So what is so if we have negative 5 to the 4th is also 625, then what is the 4th root of 625 also equal to? Negative 5. So does everybody see a pattern? It was an even root, so we have a plus and minus root. Questions on that? Okay. Let's look at degree 3. Oh, so I just said it. Even powers will always have plus and minus roots. So square roots, 4th roots, 6th roots, 8th roots, 16th roots. Anything with an even root will have a plus and minus root. All right, how about cube roots? 2 cubed is equal to 8. So what's the cube root of 8? 2. Very good. You're seeing the pattern. All right, well, look at this one. Negative 2 cubed is negative 8. So what is the cube root of negative 8? Negative 2. Now notice, when we took the cube root of positive 2 and the cube root of negative 2, did we get the exact same answer? No. So odd roots do not have 2 roots. They have 1 root, 1 exact root. So once again, I'm going to say it again. Odd roots do not have 2 roots. They have 1 exact root. So if you're taking the cube root of something positive, you're going to get a positive root. If you take the cube root of something negative, you get a negative root. Is that true for even roots? Can we take the square root of a negative number? Yes or no? So you're saying yes. Some of you are saying yes. Some of you are saying no. So elaborate. Talk to your neighbor. Ready, go. Tell them if you can take the square root of a negative number. Go. So this are the answers I heard. Yes, I heard everybody came up with yes. So you can technically take the square root of a negative number, but I heard you all say the correct thing. But if you do, you've got to pull out an I. So that's true. That's true. You can take a square root. I guess you're right. You can, but then you'd pull out an I. So that would be an imaginary root. Okay. All right. So recall that the square root of negative 1 is equal to I. So let's just quickly go through this one. The square root of negative 9 we know is the same thing as the square root of negative 1 times 9, right? So we know that the square root of negative 1 is an I on the outside, and then the square root of 9, we could break it down. 3 times 3, pulling out roots of 2, so 3i. Very good. Now, do we need to account for the plus and minus? Was it an even root? Yes. It was an even root, right? So we know that the plus and minus answer will be true. Very good. Questions on that? Yeah. So root right here, it's degree 2. I mean, it's index 2. So 2 is an even number. So even root. So square root, 4th roots, 6 roots. That's an odd root. So it only has 1 root. You don't put the plus and minus. Yeah. Yeah. And it wouldn't be an I, right? The cube root of a negative number is a negative answer. Okay. Let's do this one, the 4th root of negative 81. We know we can rewrite this as the 4th root of negative 1 times 81. Now, is it an even root? When we have the root of an even number, underneath here, we're going to pull out an I, good. And then 81 breaks down into 9 and 9, right? 9 breaks down into 3 times 3. 9 breaks down into 3 times 3. And we're pulling out groups of, in this one, we're not pulling out groups of 2. groups of 4. Very good. So we have 4 3s, so they can leave the house. So we're pulling out a 3 for those 4 3s. So our answer is 3i, and then was it an even root? So we have to account for the plus and minus root. Okay, questions on that? Okay. All right. Let's do another one. The cube root of -8. Am I going to pull out an I? Nope. We can have cube root. We can have odd negatives under odd roots. Okay. So what is this? Cube root of -8. Let's break down -8. It's the same thing as -2 times, okay, yeah. -2 times, I was going to do it a different way, but let's go with that. So -2 times 4. 4 breaks down into 2 times 2. Okay. Now, really, 4 could also be written as -2 times -2, right? That's positive 4. So we're pulling out groups of how large in this one? 3, because it was a third root. So we'll pull out groups of 3. There's 3 -2, so we'll pull out a -2 for those 3 -2s. And our answer would be -2. Do I need to put plus and minus? No, not with odd roots. Okay. Now you can check this on your calculator, guys. You take the cube root of -8, it'll give you -2. Now you could have just done it an easy way. You could say, I know that the answer is just going to be negative, done the cube root of 8, and then put a negative on your answer. Does that make sense? That's what I'm going to do in the future. All right, just a couple more. The square root of 625. You could try it on your calculator, and if you get a decimal, then you got to break it down by hand. But if you get a whole number, you're good. So go ahead, try it. What's the square root of 625? 25. So we don't need to break it down. So we get 25. Do I need a plus and minus? No. Is it an even root? Yes, so we do. Now I'm going to go back to one thing. Oh, no, I'm not. Okay. All right. So now I should have read the directions. It says find all the real roots. Were those real roots? Yes. Okay. They weren't imaginary, so they were real. All right. What about this one? The square root of -1.4. Find all the real roots. Are we going to have real roots in this one? No, because we'll pull out the -1, right? And it will be an I. So we're going to have a plus and minus imaginary solution, right? And I'm asking you to find all the real roots. So this one would say no real roots. They'd be imaginary. Does that make sense? You got to read the directions. If it just said find the roots, though, you would find the imaginary roots. Okay, so looking at this one, find the real roots. The cube root of -216. Once again, you could try it on your calculator. If you get a whole number, you're good. If it's a decimal, though, you've got to break it down by hand. Cube root of -216. -6. Very good. Now, if you needed to, you could have broke it down by hand. Then you would have just ignored the negative, got an answer, and you would have pulled out 3 6s. And you would have had a 6 for those 3 6s, and you would put a negative on it because of the negative under our cube root. All right, something like this. The cube root of 1/64. It says find all the real roots. So my question is, can I split this up? Can I split this up? Could I split up this in the past? The square root of 1/64? Could I split that up? Yes. So can't I split this up as well? So I'm going to rewrite this as the cube root of 1 over the cube root of 64. So on your calculator, you'll type in the cube root of 1 and you get 1. The cube root of 64. 4. Very good. Cube root of 64 is 4. Do I need to put a plus and minus on that? No. It's an odd root. Very good. So our answer is 1/4. Everybody see how I did that? All right. Calculators, do this one. The cube root of 0.27. 0.3. Do I need a plus and minus answer? Is that a real root? Yes. Okay, good. So that's our answer, 0.3. All right, so find all the real fourth roots. Now this one's worded differently. I'm wording it how it will be worded on your assignment. So it says find all the real fourth roots. So on number 1 here we have 0.2401. So I'm going to take the not square root, but the fourth root of 0.2401. Now we're going to do this on our calculator if it's a decimal. So do it, and you get 0.7. Okay, 0.7. Now it says find all the fourth roots. So is there another root besides 0.7? Yep, and negative. So we'll put our plus and minus in front. There's both our real roots. Now it's real because it didn't have an I, or else that would be an imaginary root. So let's look at number 2. It's asking us to find the real fourth root. So I'm doing the fourth root of negative 1,296. What kind of answer am I going to get? I'm going to get an I, you said? Yep, you're right. That's an imaginary root. And then, how many roots am I going to have? 2. So we're going to have, well, I'm choking on my gum. 2 imaginary roots. Now it says find all the real fourth roots. So what would my answer be? So you said that we got 6i, and we did plus and minus 6i. Now we're asked to find all the real fourth roots. So what would our answer be? None. Very good. Okay, none. All right, do problems 1 through 20. So my question is, can you take for real roots, can you have a negative under an even root? No, you have 2 imaginary solutions, right? Okay, so what would your answer be if you have an even root and there's a negative under it? No real roots. Good. Now, can you take the cube root of a positive number? Yes, and you'd get a positive answer. Can you take the cube root of a negative number? Yes. Would it be an I? No, it would be a negative answer. Very good. Okay, so you're getting it. Okay, so far we've been simplifying radicals with numbers. So we've been able to find the exact roots, right? Well, now we're going to be looking at radical expressions with variables under them. And we're going to simplify these. So we're not going to be able to find an exact answer, but we are going to be able to simplify them. Now here's the new rule. This is not new to you, simplifying radicals. It shouldn't be. You should have learned it in secondary 2 and 1 even. But today we're going to learn a new rule, and you will be tested on it on the end of levels and in this class, okay? So we know how to pull things out of roots. That's not new to us. But now this is the new rule. With radical expressions, you have to know this even, odd rule. So even, odd, you want to know this, okay? So what the even, odd rule says is that if you have an even root and an even power underneath, and you simplify it, and in the end, you get an odd exponent as an answer, then you have to add in the absolute value signs around your final answer. Even, odd. So I'm going to just say that again. If you have an even root and an even power, and then your final answer has an odd exponent, you have to add on absolute value signs. Now here's the reason. We have to add on those absolute value signs because we cannot have a negative underneath the root. So if you have this odd exponent, it won't fix the negative. If we were to plug in an answer, it won't fix the negative because negative 2 to the first power is still negative 2, right? So we'd be inputting a negative under an even root, and we can't do that. So that's why this even, odd rule happens. So it has to go in that order, even, odd. So if it's odd, guys, if it's odd, you're not going to need absolute values in your answer. If it's even, odd, you're not going to need absolute value signs. You'll know it. Does that make sense? So it's only if it's even, and then comes out odd. So if it would have come out even, and then even, we wouldn't need absolute value signs. So everybody kind of understand. It'll make more sense once we practice it. So you'll just do these like any other problem, and then in the end, you'll say, do I need absolute values? Check for even, did my answer come out odd? If you say yes to all 3 things, you'll add in absolute value signs. Okay, you have this down so we can just practice. Yes or no? Okay, now I need you to pay very close attention to this next part. There's two different ways of doing this problem, and now that we're more advanced, we need to do the easier way, but it takes a little bit more advanced thinking. Okay, so it says simplify the square root of 16x to the 8. Now notice it doesn't say find all the real roots, so we're not going to have plus and minus answers. We're just going to simplify it, and our answer will be what our answer is. So we can look at this by breaking it down individually. So I'm going to do this the long way first. So 16 breaks down into 4 times 4. 4 breaks down into 2 times 2, and 4 breaks down into 2 times 2. Is everybody following me up to that? Now, if we were desperate, we could rewrite x to the 8 as 1, 2, 3, 4, 5, 6, 7, 8 x's, right? Okay, and then we're pulling out groups of how large. So if there's 2 of them, since it's a square root, we're pulling out groups of 2. If there's 2 of them, they can leave the house. If there's not, it has to stay underneath. So we have 2 2's right there that we can pull out. So I'm going to write it over here. We have 2 2's right here, so we can pull them out. Now they're coming out in groups. Do we multiply those both out on the outside? Do we pull out a 2 and a 2 for those 2 2's? Do we pull out a 4 for those 2 2's? No, we pull out a 2. Good. And then we have these 2 x's right here, so we'll be pulling out. So we pulled out a 2, we pulled out a 2, we pulled out an x now. Because of those 2 x's, we'll pull out another x. We'll pull out another x because there's 2 of them. And we'll pull out another x because there's 2 of them. Was there anything left under my house? No, so the house went away. Now let's multiply all this together. 2 times 2 is 4. And then x times x times x times x is x to the 4th. Now let's check to see if we need to add absolute value signs. Now this won't work for, this isn't for numbers. It's not, that numbers, it's not going to apply, but variables, yes. Were we even root? Even power? Did we have an odd exponent in our answer? No, so we do not need absolute value signs. The negative will be taken care of if we were to plug something in by that 4th, because negative 2 to the 4th will be positive. Yes? Great question. Such a good question. Would we, if it was odd, would we add absolute value signs around the whole thing? And the answer, that's a great question. Love that you asked it. The answer is no, just around the thing that needs to be fixed. Yeah. So this is our final answer. Now, guys, do you want to write out all those x's every time? What if I gave you x to the 100? Yikes, right? Okay. So we were going to think of this more advanced. And now that we're in secondary tree, we should be able to. Okay. So think about this with me. We're pulling out groups of 2, right? So now focusing, well, with 16, guys, you'll have to just do the square root of 16. You'll just have to do that as normal. So you could try it on your calculator. Square root of 16, you get 4. But if it was a decimal, you have to break it down. But for this, I'm teaching you a trick now. Well, if you think about it, we're pulling out groups of 2. So we know that we have 8 x's. How many groups of 2 are we going to have? So what you'll do, you're thinking about how many groups of 2 do we have in x to the 8, right? So you can go off to the side, take your exponent and say, how can I break 8 up into 2? How can I divide it into 2? What's 8 divided by 2? 4. Was there any remaining? It was simply 4. So we're pulling out x to the 4th. Because think about it, guys, if we're splitting 8 into groups of 2, that'd be x to the 4th times x to the 4th. Isn't that x to the 8? Yeah? And then pulling out a group of 2, we pull out those 2 x to the 4th, and we get x to the 4th on the outside. So wasn't this much quicker than writing out all our x's? Yeah, so that's a little trick. Let's do another one. Square root of 9a to the 14th. So the square root of 9a to the 14th. Let's use our trick. So let's just do, what is the square root of 9? 3. Does everybody know that the square root of 9 is 3? If you didn't know that, you'd do it in your calculator. If you got a decimal, you'd break it down and pull out groups of 2. All right, so we want to know, how can we split a to the 14 into 2 groups? Good. You'll take 14 divided by 2, and what is that? 7. So is there any remaining? No. So we're going to have 2 a to the 7th, right? Pulling out groups of 2, we would pull out an a to the 7th. That's our final answer, right? Does everybody see how much quicker that was? Now, remember why this works, because really we have 9 times a to the 7th times a to the 7th, right? Same thing as a to the 14th. So pulling out groups of 2, we would have pulled out a to the 7th. Does everybody see how you're doing this in a just kind of quicker way? Now let's check to see if we need absolute values. That's not new, guys. You should know how to do this. The new thing today is the absolute value signs. So was it an even root? Was it an even power? Was it an odd exponent in our answer? Yes. So we need absolute value signs around that a to the 7th. And then we're good. Because if we absolute value means just the positive distance. So that would fix any negatives. All right. Couple more, and then I'm just going to let you work the rest of the time. Okay. Now let's just let you practice. 21 and 22. Practice those two. Then I'll let you work. Okay? So let's do this one. The cube root of 8a to the 6th, b to the 9th. So now we're pulling out groups of how large? 3. Good. So let's just, first of all, the cube root of 8, you'll just do that by hand. 4 times 2. 4 breaks down into 2 times 2. Pulling out groups of 3. So we'll pull out a 2 for those two 2's. Now this time, we'll use our trick way quicker. We want to know how can we break a to the 6th up into groups of 3. So you'll take your exponent, say, how can I break 6 up into 3 evenly? 2. So 6 divided by 3 is 2. So if you think about it, a to the 6th is the same thing as a to the 2nd times a to the 2nd times a to the 2nd. 2, 4, 6. And then we're pulling out groups of 3, so we'll pull out an a squared for those 3 a squareds. So we're pulling out a squared. There was no remainder, right? If there was, though, there'd be something remaining under the root. Now, b to the 9th, how can we split 9 into groups of 3 evenly? 9 divided by 3 is 3. So we'll be pulling out also a b cubed. Now, check to see if you're dealing with even, odd. Is this even? No. So we know we don't need absolute value signs. That's our answer. Okay. Questions on that? Okay. Last couple examples. The fourth root of x to the 8th, y to the 12th. We're pulling out groups of how big? 4. So how can we break 8 into groups of 4? 2. So we're pulling out an x squared, and then 12 divided by 4 is, so y cubed. Check your even, odd. Check even, odd. What do I need absolute value signs around? Even, odd? No. Even, odd. So we'll put it around y. I was going to do these two, which you're going to struggle with, but you're obviously not wanting